Okay, guys, so we are starting, this will be the last section for Chapter 4. It's a pretty easy concept to understand. Something we've kind of already done. We've kind of worked out the long way to figure out the area from one point to another. And I'm going to just show you a couple other ways that we've done it. So we did Riemann sums at the beginning of the chapter, right? We did left Riemann sum, right Riemann sum, midpoint, trapezoid rule. So that's one way that you can find area. Definite integrals is another way. Okay, now in order to find the area, right, you would need to have an equation. Then you have to find the antiderivative, and then you're going to go from one point to the next one. But you're not always going to have an equation in front of you. Okay, so sometimes you're going to have a picture where you're going to need to figure out the area from that. Okay, so a lot of your questions are going to be figuring out the area as you start at this value. Okay, so we always start at the value that's on the bottom, and you end at the value at the top. Okay. And typically you would read that on the graph going from left to right. So the value here at A would be more on the left, and then the value at B would be more on the right. Okay. So an idea that we need to kind of get into our heads is that the integral, the definite integral of a function, does not give us the area, but rather the net accumulation over that interval. Okay. So, for example, right, I have a graph here, right, and it says it's v of t, okay, and we're going to go from, say we'll call this x equals 1, and over here we'll call this x equals 10. Okay, now the different colors represent the areas of this graph. So if I said this was like x equals 4, and then this is like x equals 7, and then the last one obviously is x equals 10. Okay, so if I asked you guys, all right, you're doing the area as you go from 1 to 4 of this function, okay, your answer, because this space, all of this space is above the x-axis. As I'm going from left to right, this space is above the x-axis. My area is going to be positive, and my definite integral is also going to be positive. So this would be positive a1, okay, a sub 1. All right. Now, if I were to ask you guys to do, okay, now do the integral from 4 to 7 of v of t dt, okay, this space here is below the x-axis, okay? So what that means is that as I go from the left point to the right point, and the space, the curve, going from the curve to the axis is below, okay, that makes this space has to be negative. So this is going to be negative. Okay, so if I were to ask you for the definite integral as you go from 4 to 7, this is going to be negative a2, okay? And then, so this is positive. All right, and then this last one, say we were to do the area from 7 to 10 of v of t dt, okay? Again, this space here from the axis to the curve is above the x-axis, okay? So that means that it is positive a3, okay? So when you go from left to right, things that are above the x-axis become positive. Things that are below represent negative. So you're losing part of your answer if you have space that's below the x-axis. You're taking it away. Okay. So that's highlighted in this first point here. When integrating from left to right above the x-axis, regions above are positive. Regions below are negative. All right. So that's something very important to kind of keep in mind. Okay, now the second concept is just the opposite of that. So if you're integrating from right to left, okay, regions above now become negative, and regions below become positive, all right? So it's like you're working backwards, okay? So everything kind of just switches if you're going from right to left, okay? So for example, I'm going to do this in a different color, and I'm going to erase some of this. Now, if I were to ask you guys to do, say, the integral from 4 to 1 of v of t dt, okay? So I'm starting here at 4, and I'm ending at 1. So I'm starting on the right, and I'm ending on the left, okay? Now, because this region is above the x-axis, and I'm going from right to left, this now becomes negative a1, okay? And again, everything is just switching now. So if I were to do the integral from 7 to 4, okay, now that region, I'm going from right to left, and that region is below, okay, so that region now becomes positive, so that becomes positive a sub 2, okay, and then the last one, if I went from like 10 to 7, I'm going from right to left, this would be negative a3, okay, so you just need to pay attention to the numbers, the limits on your definite integral to help you figure out whether it's positive or negative. Okay, and the rule that you guys can do is this one here. So if you're doing the integral from a to b of f of x dx, you can switch the limits, all right? You can make b now on the bottom and a on the top, okay? And the only thing you have to do from that is you need to put a negative in the front, okay? So if we know, for example, from looking at the picture, we know that from 1 to 4, we know that that's positive a1. Now, if I just went from 4 to 1, my answer becomes the opposite, so negative a1, okay? So again, we're just paying attention to the direction and then whether it's above or below the axis. All right. Now, another rule that you guys can use, okay, so if you have two regions, right, and you can combine your integrals, all right? Now, for example, if I wanted to say, go back up to this picture, all right, I'm going to erase some of this. Erase some of that. Okay. So for example, say I wanted to tell, figure out, okay, what exactly would be the integral if I went from 1 to 7 of this function, okay? What combination could I make of that, all right? So that's a combination of doing the integral from 1 to 4, v of t dt, and then adding with that the integral from 4 to 7. All right. Now, pretty obvious that would be from 1 to 4, it would be a1, and then 4 to 7 would be negative a2. Okay, so your answer would be a1 minus a2 as your area. Okay, so a big thing to keep in mind when you're adding definite integrals together, okay, if the top number here matches with the bottom number on the second part, okay, so these two numbers need to match each other, okay? If they match each other, okay, and if you can imagine condensing these two integrals together, what you're going to be ending up with is the integral from 1 to 7, okay, which is what we have over here, okay? Now, the only way, again, that it works is if the top number on the first one and the bottom number on the second one are the same thing, okay? If they're not, then you can't put them together. Okay, so it says that we have a graph from -4 to 4, and it says A1 and A2 are positive numbers that represent the areas of the shaded regions. Find the following. Okay, so this first one, right? I'm going from -4 to -1, okay? Now, A1 is above the x-axis, okay? So my answer is just A1. Now, if I go from -1 to 4, -1 to 4 is below the x-axis, okay? So the definite integral there is A sub 2. All right? Now I'm going from 4 to -1. Now I'm working backwards. So as I go from right to left, A2, since it's below the x-axis, now becomes positive. So I'm sorry, let's back up. So from -1 to 4 from the second one, right, that should be negative because that's below. Okay, and then when I do the third one now, as I go from right to left, that becomes now positive A2. Okay, now if I'm doing from -4 to 4, right, that's really like I'm doing the integral from -4 to 1. Is that 1? No, -1, sorry. From -4 to -1, and then you're adding with that the integral from -1 to 4. So it's putting the two together, okay? So from -4 to -1, we know that that's A1, and then from -1 to 4, that's going to be negative A2 because it's below. Okay, and then the last one, you have absolute value signs. Absolute value. Okay, so what that means is that you make all regions are going to be positive. So all regions become positive. Okay, so from -4 to -1, we already know that that's positive A1. Okay, and then from -1 to 4, that now is going to become positive A2 because of the absolute value signs. Okay, so this will now become A1 plus A2. Okay, so for number 2, we have a graph, and it says evaluate from -7 to 0, and then from 2 to 5. Okay. All right, so now because you don't have an equation, what you're going to have to do is use some geometry to figure out the areas. Okay, so I see from -7 to this is -2. That's a triangle, right? So we have a base of 5, okay, and a height of 1. All right, so 1/2 the base would be 2.5 times the height, which would be 1. Okay, so this area is going to be 2.5. All right, now I have a semicircle going from -2 to +2. Okay, which has a radius of 2. All right, so a semicircle. Okay, that's pi r squared over 2. Okay, so if I know that the radius here is going to be 2, right, this is then going to become 4 pi over 2, or just 2 pi. Okay, so this whole thing from -2 to +2 is 2 pi. So if I split that in half, from 0 to 2, it's just 1 pi, and then from -2 to 0, it's another pi. Okay, so if I'm doing the integral now from -7 to 0, okay, from -7 to -2, it's below the x-axis, so it's -2.5, and then from -2 to 0, it's above, so it's going to be plus pi. All right. Okay, now you have the second one is going from 2 to 5. All right, now 2 to 5 looks like we have some triangles. All right, so this looks to be about 4.5. Okay, so that means that the base is going to be 2.5, right? Half of that is 1.25 times the height. So we have 1/2 times the base, which is 2.5, times the height, which is 3. Okay, so if you multiply that out, we get 3.75. Okay, so from 2 to 4.5, that's 3.75. All right, now if I go from 4.5 to 5, that's another triangle. Okay, so 1/2 of the base, which is a half, times the height, which is 1, so this is 0.25. Okay, so if I'm doing the integral now from 2 to 5, all right, I'm going to have 3.75 because that's above, and then minus 0.25 because that's below. So my answer is just going to be 3.5. All right, so sometimes you need to use your geometric formulas to help you figure out the areas. And that's what we have to do again here. So for the first one, we're going from 0 to 1. So from 0 to 1, which is just a rectangle. So you have 1 times 2. All right, so that's going to be 2. All right, now we need to go from 2 to 3, which is just a triangle. So 1/2 of the base, which is a half, 1/2 times 4, which would be 2. Okay, so from 2 to 3, our area is also 2. Next one says to go from 2 to 4. Okay, so 2 to 4, 4 is right here. All right, now the area of that is going to be 0.5. Okay, now because that region is below the x-axis, I have to take that away. So I'm going to have 2 minus 0.5, which is just going to be 1.5. All right, and then the next one is 3 to 6, okay, which is here. All right, so we have 0.5. Now sometimes you have to split them up, right? You need to do each kind of shape separately. So we already did the triangle from 3 to 4. I know from 5 to 6 that's a rectangle, which will just be 2. Okay, and then this other one is a trapezoid, right? So we have so the area for your trapezoid, right, is 1/2 times the height, and then the sum of the two bases. Okay. Now the bases you guys can use here and here. Okay, and then here is going to be your height. Okay. So in this case, it's 1/2 times 1, and then the sum of the two bases are 1 and 2. Okay, so this is going to give me 0.5 times 3. All right, so half of 3 is just going to be 1.5. Okay, so let's put them together now. So from 3 to 6, we have negative 0.5 minus 1.5, which is negative 2, minus another negative 2 is negative 4. Okay, and then for letter E, we're going from 7 to 3. Okay, so now we're working backwards. So here is 5, here's 6, here's 7. Okay. All right, so this is going to be 1, because that's a triangle. All right, so as we go from 7 to 3 now, we're working backwards. So this is now positive 1 plus 2, which is 3, plus 1.5, 4.5, plus another 0.5, which is 5. So that should be positive 5. All right, so now we're going from 5 to 2. All right, so we have 1.5 plus 0.5, so that's 2, okay? And then from 3 to 2, we have to take away 2 because that region is above the x-axis. So that's just going to be 0. All right, and then the last one says to do from 0 to 7. All right, now the only region we haven't found yet is from 1 to 2. So that is 1/2 times 2, 4, that's 6. That's 3. Okay. So now we're just going to add everything up. So we have 2 plus 3 plus 2, which is 7. Okay. Minus 2 is 5, minus another 2 is 3, minus 1 is positive 2. Right? And then if we do the absolute value from 0 to 7, everything becomes positive. So 2 plus 3 is 5, plus another 2 is 7, plus another 2 is 9, plus another 2 is 11, plus another 1 is 12. All right. So if you guys, again, just split them up, it's pretty easy to work on it from there. And then you can just use them for other problems. Okay. And then we had talked about sometimes you're not always going to have even a graph, right? Sometimes it'll just give you some information that you're going to have to figure out. So they gave you some values for f of x and g of x, okay? Now this first one says you need to do the integral from 1 to 2 of g of x, okay? Now if I look at both of the ones I have for g of x, neither of them are from 1 to 2, okay? However, I can switch one of these, right? So, and I can add them together, right? Now in order to add them together, this top number needs to match up with this bottom number here, okay? Now, as they're written right now, they're not, okay? But if I switch this first one, okay, we can make that then from 1 to 0 of g of x, okay? And if I add that with the integral then from 0 to 2, now my top number on my left matches the bottom number here on the right. So this matches here, okay? Now, if I'm going from 1 to 0, I just have to make it the opposite of what it is from 0 to 1, okay? So this becomes now positive 1, and then from 0 to 2 becomes 4, so my total is going to be 5. All right, so sometimes you might have to work it out that way in order to get your answer. Okay, and then from the second one, we have 2f of x minus 3g of x. Okay, so what you guys should do for this is you're going to do 2 integral from 0 to 2 of f of x, and then you're going to add or subtract that integral from 0 to 2 of g of x. All right, so if you have a constant like that, you can move that out front. You're perfectly allowed to do that. Okay, now again, I don't have 0 to 2 of f of x, right? But if I add these together, right, this top number here matches the bottom number there, I can just add them together. So the integral from 0 to 2 is going to be 2 plus 3, or 5, okay? So this is going to be 2 times 5 minus 3 times from 0 to 2 is 4. So this is going to give me 10 minus 12, or negative 2. Okay. Now the third one, you're going from negative 1 to 1, right? Now, if you're starting and stopping in the same place, you're not gathering any area whatsoever because you haven't moved anywhere, right? So if you don't move at all, then your answer is just 0. Letter D, going from 1 to 2 of f of x, okay, which we know is 3, plus 2 to 0 of g of x, okay? Now we know from 0 to 2 is 4. Now if I just switch that, that becomes negative 4. So your answer would be negative 1. Okay? And then the last one, you got 0 to 2 of f of x, which we already figured out was 5. And then from 2 to 1, okay? Now we already figured out from part A that from 1 to 2 of g of x is positive 5. So from 2 to 1 just becomes the opposite, or negative 5. So then your answer becomes 0. Okay, so that is how you guys would do definite integrals with the area from a graph. So if you guys have any questions, let me know. Thanks.